This problem asks to find various properties at states 1 through 5 for R134A and to plot them on a TS diagram. It's clearly a state problem since we're evaluating properties at 5 separate states. So in test, we'll want to go to test calcs and system states. And then since R134A is a refrigerant, and in refrigeration systems there's various phase changes, the PC model is the best choice. And we'll go to either PC test app or test calcs. And select R134A in the top right hand corner in the fluid selector. And now we're ready to enter the known properties. So for state 1, we're given that T equals negative 60 degrees Celsius and that it is saturated vapor. So in test calcs, we'll check temperature and enter in negative 60 degrees Celsius. And since it's saturated vapor, the fraction will be 1, which means that it would be at the G point on the curve in the TS diagram. So now since we have two thermodynamic properties, we're able to calculate the rest of the thermodynamic properties just by hitting calculate. As you can see, we now have S1, which would be Sg at negative 60 degrees on the TSAT table. So on to state 2, which we are given is 1000 kPa and isentropic to state 1, which means that the S value is the same as state 1. So we go back to test. We switched from state 1 to state 2 up in the left corner. We know that P2 equals 1000 kPa and that S2 equals S1 because it's isentropic. And again, we have two thermodynamic properties, so we can calculate the rest of them. And on to state 3, which we are given that it is isobaric to state 2, which means it has the same pressure as state 2, and it's saturated vapor again. So again, isobaric means same pressure as state 2, so P3 equals P2. And again, it's saturated vapor, which means that fraction will be 1. And then we can hit calculate again because we have two thermodynamic properties. And we get the rest of our values. Alright, next is state 4, which we are given as isobaric to state 3 and saturated liquid. So we switch to state 4 up in the left, and it's isobaric to state 3, which means P4 equals P3. And now it's saturated liquid, so this vapor fraction would be 0, which means it would be at the F point on the TS diagram. Okay, and again, we have our two properties, so we hit calculate, and we get the rest of our properties. And up in the right corner, it says saturated liquid. All right, on to state 5, last one. We're given that it is isobaric to state 1 and isenthalpic, which means a constant H value to state 4. So in test, we switch to state 5, and it's isobaric to state 4, so to P1, and isenthalpic to state 4, so it equals H4. And then we can calculate, and we get the rest of our properties. So now the last part of the problem is to plot all of these properties on a TS diagram. So test has this capability. Go back to test. And since we have all 5 properties that we're looking for, we can go to the graphics panel and it automatically opens a TS diagram. You can switch to different diagrams, such as HS or TV, but we're looking for the TS diagram in this problem. Just play around with this, it's really helpful. You have the constant pressure lines, which you can turn on and off. You can zoom in or out, either using the plus or minuses or by dragging a box over it. Reset the zoom to the original. And you can join the states together if you want or not. So there is our TS diagram. So a good point to also bring up is that if there was like a what if scenario question and it said that actually state 1 is going to be negative 50 degrees Celsius. Well, that's why in all of these problems, instead of entering the exact values of S2, like 0.9987, instead of equals S1, is that once we change that value to negative 50 instead of negative 60, and then hit super calculate up in the middle right here, it'll recalculate all of the values for each of these states. If we hadn't done that, then you would have to go through each state individually and change all the values. This way is a lot easier and better for avoiding mistakes. So the point I'm trying to get at is whenever it says it's isentropic or isobaric, or you know that it's going to be the same as the state before, always try and use equals S1 or equals P2 wherever you can, because you'll avoid so many errors and it'll make solving the problem a lot easier.